So projection of straight lines inclined to both HP and VP. Projection of straight lines inclined to both HP and VP. Here the straight line is inclined to horizontal plane as well as it is inclined to the vertical plane. So neither of the view, that is either front view or the top view, will not give the true length initially. So for that what we have to do? We have to rotate the line parallel to VP first and we have to construct the appropriate view. Later on we have to rotate the line parallel to HP and we have to construct the appropriate views. So for that we have a template and that template has been already explained in the previous session. Okay, that template I have shown here. So you can see here, you can see that. So initially you have to construct the XY reference line. Okay, then the line is named as AB. So the end A is how much above HP, this one, and the end A is how much in front of VP, that is this length. Okay, then this is the true length of the line and this is the theta represents the true inclination with respect to HP. And here you can see that this is the true length of the line and this pi represents the true inclination of the line with respect to VP. And this A dash B dash represents the front view and AB represents the top view, actual front view and top view of the line. So this concept we have already discussed in the previous classes and this is the template which we are going to use for solving the problems. So in that way we can solve one or two problems in today's class. So for that I have given a problem here. So I have given a problem. This is the first problem in your problems for practice which has been given in the Moodle classroom. Okay. So here you can see that a straight line AB of 80 mm long, a straight line AB of 80 mm long has its end A. How much mm? It is 10 mm in front of VP and 20 mm above HP. The line is 30 degree to HP and 45 degrees to VP. So by reading the problem itself, you can say that the line is 30 degree to HP and 45 degrees to VP. So here the line is inclined to HP as well as it is inclined to VP. So both theta value as well as pi value is given. Now we can say that what is the true length of the line. So which one is the true length of the line? This is the true length. A straight line AB 80 mm long. 80 mm long is the true length of the line. So the true length is 80 mm. True length is 80 mm. Okay. Now what about the end A? You say that the end A is 10 mm in front of VP and 20 mm above HP. That is the end A is 10 mm in front of VP. So you can see that the projection of straight lines, we look the projection of straight lines only in the first quadrant. So imagine the first quadrant. In the first quadrant, XY is the reference line, that is the intersection of both VP and HP. You can say that it is 10 mm in front of VP means it is 10 mm below the XY because we always rotate the vertical plane through 90 degrees in the clockwise direction. So when you rotate it, it will come below XY. Okay. And similarly, this one is the above XY. It is the line is 20 mm above HP. The end A is 20 mm above HP means it is 20 mm above the XY reference line. Okay. So that it is end A. A is 10 above HP. Sorry, it is not above, it is in front. Okay. A is 10 in front of VP and A is 20 above HP. A is 20 above HP. Okay, it is 20 above HP. Now you can see that 30 degree to HP. The line is 30 degree to HP. So this is the horizontal plane inclination is always denoted by theta. Vertical plane inclination is always denoted by pi. Okay, so you can say that theta is equal to 30 degree and pi is equal to 45 degree. Pi is equal to 45 degree. So these are the given data in the problem. So now to solve the problem, you can use this template to get the front view and top view of the line in the given position. Okay, now let me start with this one. So that is the end A. End A is 10 mm in front of VP and 20 mm above HP. So for 10 mm in front of VP, I take 10 mm below XY. You have to take 10 mm below XY. So 10 mm below XY, I draw a locus line. Draw a locus line. So this is, so you can say that this is 10 mm. So this is 10 mm in front of VP. And again, this is 20 mm above HP. 20 mm above XY. Okay. So you take 20 mm. Okay. So this distance should be 20. This is 10 and this is 20. So now here, so this is 20. Okay. Now I fix the end A. So I fix the end A. Let me take this as end A. Okay. You draw a vertical line from here. So this is end A. A can named as A dash. This can be named as A. Because always you know that in projection of points we have seen that end A is a point. The point front view of the point can be named as A dash. Top view of the point can be named as A. That is what we discussed in projection of points. Okay, right. So now you come to this. Theta is equal to 30 degree. The line is inclined at 30 degree to HP. So 30 degree to XY. Now from here I have to take 30 degree. So this is a protractor. It's a protractor. You use your protractor. You keep your protractor here. Okay. And you take 30 degrees. You take 30 degree here. Take 30 degree. And draw a line joining A dash with the point. Okay, right. Now I have drawn 30 degrees. So this angle is, so you have to mark this angle. This angle should not be marked in free hands using a pro circle. Using the small circles in the pro circle, you use 18 mm diameter circle for marking this arc. Okay, right. So this is theta equal to 30 degree. I have marked. Now what is the length, true length of the line? It is 80 mm. It is given. So what I can do? So you take the compass. You take the compass, and in the compass you measure the true length 80 mm. Okay, right. You take your compass, you measure 80 mm in your scale. Okay, with 80 mm as diameter, like this, you can cut an arc here. You can cut an arc. So now this length is 80 mm. This length is 80 mm. So you can name this one as B1 dash. You can name this as B1 dash. Now you draw a locus line through this B1. have drawn a locus line using through this B1 dash. Okay, right. So now this A dash B1 dash represents the true length of the line, that is 80 mm. Similarly, you can take this pi. Pi is given as 45 degrees in the problem. So I can take again protractor. You keep your protractor like this. Okay. And now you take 10, 10, 20, 30, 40, and it is 45 degree. It is given as 45. So now I have taken 45 degrees. So through 45 degree, you drop a line from here. I have drawn a line through 45 degrees. Okay, right. So now you take again your compass. You take again your compass. Again take the true length, which is 80 mm. True length is 80 mm. So again I take the true length 80 mm and I keep it here and I draw an arc here. I draw an arc. So with this point A as center and 80 mm as radius, I have drawn an arc here. Okay, right. So now again you draw a locus through this point. So a locus is drawn through this point and this can be named as B2. This can be named as B2. Okay. Now this represents the true length of the line. This represents again the true length of the line. Okay, right. Now what we can assume, since here that this top view is in true length, this one is in true length, what you can get the reduced front view from this. This one is true length, so you can get the reduced top view length from this. How to get it? So you project a vertical line from here. From B2, you project a vertical line. Project a vertical line. So this one is B2 dash. This is a vertical line. Okay. Then similarly from B1 dash, you project a vertical line to the opposite locus, to this locus. Now this is B1 dash. So this is B1 dash. So this should be B1. This one should be B1. Okay, right. Now what we can do? Now again you take your compass. Again take your compass with A dash as center and A dash B2 dash as radius. You rotate this. So you can rotate this. Okay, you draw an arc like this. Draw an arc like this. Similarly, with A as center and A B1 as radius, you can rotate this. Can rotate this. Okay, right. So now we can see that this one can be named as B and this one can be named as B dash and be named as B dash. Okay, so now you can say that if you join this A dash B dash, that will give your actual front view. So this A dash B dash gives the actual front view of your line. Similarly, if you join this AB, join this AB, this gives the actual top view. This gives the actual top view. So here you can see that this one is the front view of the line. This one is the top view of the line. You can see that the front view as well as the top view both are in reduced length when you compare with the true length of the line. Okay, right. So you have to rotate this in this direction. This one is in this direction. Now we can draw a vertical line from B dash. So if you draw a vertical line from B dash, definitely it will pass through B. Definitely it will pass through B because A dash A and B dash B are the end projectors. Okay, so if you draw a vertical line, definitely it will pass through B. Draw a vertical line, it will pass through B. This is one of the check measure also. This is one of the check measure. Where into ஒரே vertical line la வரலைன்னா, then we can say that we have made some mistake in our drawing. So now I have completed the projection of the straight line AB. It is 80 mm long and the end A was 10 mm in front of VP and 20 mm above HP. The line was 30 degree to inclined to HP and 45 degree inclined to VP. So for that I have constructed the projection and I have drawn the front view and top view of that particular line. So this is a systematic procedure you have to follow to get the projection of straight line when a straight line is inclined to both HP and VP. Okay, then after constructing this you can mark the given data. So what are the data given? True length of the line is 80 mm. So how to mark the true length? So you have to mark the true length. The true length is available here as well as here. Say any one is enough. Any one you can mark. So how to mark the true length? The true length, the line you have to take a ladder line which is like this. You have to take a ladder line which is perpendicular to the true length. True length ku 90 degree la irukanum. So from here you have to take this. Now this should be exactly parallel to the AB2. Okay, this is exactly parallel to AB2. Draw the arrowhead in the 1:3 ratio. Now I have done it. Now what is the value? The true length of the line is given as 80. So I can write this as 80. True length I have marked that 80. Now theta is marked as 30, pi is given as 45. So I can mark the value of pi as, so this one is pi which is equal to 45 degree. Pi is 45 degree. Now you have to see that another two datas are there. What are they? This one, if you see that, this is alpha. This one you can see that this is beta. Alpha is the angle of the front view with XY reference line and beta is the angle of top view with respect to the XY reference line. Okay, right. So if it is asked in the problem, you can mark alpha and beta. If it is not asked or it is not a given data, means you can skip that. Okay, right. So now you have marked theta, pi, true length. Then what about A is 20 above HP and 10 in front of VP. So all the given datas I have represented in my problem. Okay. For example, if it is a problem number 1, you can write this as problem number 1 and using a pro circle we can make a circle around that. So this is how to construct the projection of a straight line which is inclined to both horizontal plane as well as the vertical plane. Okay, if you have any clarifications, feel free to contact me.